The battlefield has become more accessible to laser weapons. According to Tyler Griffin, Lockheed's head of laser and sensor systems, the company is working on a 50 kilowatt laser dubbed Deimos, which stands for Directed Energy Interceptor for maneuver or short-range air defense. Stay tuned for today's video in which we'll go over all you need to know about Deimos. A quick overview of the history of high-energy lasers. Since the 1960s, the US military has been considering electromagnetic spectrum weapons. Industry and the military worked together in the 1980s to figure out how to achieve viable power level, beam control, and adaptive optics. In 1999, the Department of Defense designated lasers as a possible future weapon, signaling the start of formal research and testing. However, the U.S. Defense Advanced Research Projects Agency fired a 100 kilowatt laser in 1968, and the Navy ARPA chemical laser produced 250 kilowatts in 1975, demonstrating limited use lasers earlier. Of course, to understand what today's lasers require in terms of onboard electronics, we must first understand how a laser operates. Lasers generate focused, coherent light of a single wavelength, and their technical name is light amplification by stimulated emission of radiation. The source of power utilized to stimulate the photons that compose the beam is referred to as a solid-state laser. A rod formed of a solid medium such as glass, crystal, or a gem, and an active substance such as chromium, titanium, or other materials serves as the tasing mechanism in a solid-state laser. Because they can be manufactured to fit in small locations, are relatively affordable, and can operate on batteries, these lasers are frequently employed as rangefinders and target designators in addition to being weapons. In 2009, the Navy tested a prototype solid-state laser against drones with a claimed beam output of 30 kilowatts. In August 2014, the USS Ponce, an amphibious transport dock ship, carried an AN-SEQ-3 laser weapon system to test it against swarming boats and unmanned aerial vehicles. The Deimos is a 50 kilowatt class laser weapon planned to be integrated into a Stryker vehicle, similar to the Directed Energy Maneuver Short-Range Air Defense, or DEMSHORAD, prototypes that the Army has commissioned Cord Technologies to manufacture. The contract was awarded to a KBR affiliate in mid-2019. Cord then granted Northrop Grumman and Raytheon Technologies subcontractors to bid for the laser module as the program's prime contractor. The battle was supposed to finish with a shootout between the two corporation squads. The Cord and the Army would then choose a winner and install the laser module on 3 more Strykers to create a platoon's worth of SHORAD devices capable of focused energy. However, Northrop had issues with Cord's power and thermal management system when it was connected to their system, and a fire broke out during testing late last year. Due to the problems that lingered into the new year, Northrop withdrew before the demonstration. The Raytheon team went on to show its technology, and the Army decided to use those prototypes. The laser weapon was purchased for $123 million by the firm. DEMSHORAD. Before we go into the video, let's speak about DEMSHORAD for a moment. The DEMSHORAD is one of the numerous laser weapons that the military has recently begun to employ. At the Grafenwohr training area in Germany in 2018, soldiers from the 2nd Cavalry Regiment tested the Mobile Expeditionary High Energy Laser. A 50 kilowatt laser weapon installed on a Stryker infantry carrying vehicle is the Directed Energy Maneuver Short-Range Air Defense System. Consider a high-powered beam of energy focused on a target rather than a Stinger missile. According to the Army's Rapid Capabilities and Critical Technologies Office, the first systems will be shipped to Fort Sill, Oklahoma in September 2022, where they will undergo further development at White Sands Missile Range in New Mexico. Last July, the Army held a combat shoot-off at Fort Sill to test 2 direct energy weapons. According to the agency, Northrop Grumman and Raytheon Systems took part in a series of vignettes designed to replicate genuine threats and battle scenarios. In these vignettes, there were situations using unmanned aerial vehicles, rockets, and mortars. So, you're probably wondering, why are lasers used in the first place? Well, it's about the lift. Light does not weigh as much as ordnance. The direct laser weapons would constitute a significant technological development for short-range air defense operations, a region that the military frequently overlooked throughout the Iraq and Afghanistan wars. Lasers have become a higher priority since the Army has begun to focus on near-peer opponents such as China and Russia, who already use the sorts of assets that the system is meant to neutralize. It's also part of a bigger Defense Department quest for direct energy weapons. In addition, the Navy has been testing a direct energy weapon of its own. So back to the Deimos. One has already been deployed and successfully tested in the Army's MSHORAD system, and 3 50-kilowatt laser systems will be delivered in the next 18 months. The Air Force Special Operations Command, and the Navy are also incorporating 50-kilowatt systems into their own equipment to conduct identical laser weapon performance testing in real-world tactical settings. Meanwhile, researchers working for the Office of the Secretary of Defense's High Energy Laser Scaling Initiative are attempting to boost 4 laser systems to 300-kilowatt class power for future military armaments. Lockheed proposes to create a digital twin of Deimos that will serve as an exact virtual counterpart for the system, enabling faster development and testing of systems adjustments and enhancements. Its experience with other directed energy initiatives such as the indirect fire protection capability, high-energy laser it's developing for the Army alongside Dynetics might help it manage the system's size, weight, power, and cooling. Deimos will be distinguished by Lockheed's concentration on sustainability, not only the system's price, but also its cost per kill and upkeep. 40 years in the future. The Pentagon has its sights set on the future. The Office of the Chief Scientist for Directed Energy of the United States Air Force began evaluating the possible relevance of directed energy weapons in 2016, 2 years ago, a century after the military invested its first $1 million in laser technology. The research, titled Directed Energy Futures 2060, was published at the end of June 2021. It was hopeful but realistic in its appraisal of weapons based on electromagnetic energy beams, such as laser beams, radio frequency devices, high-power microwaves, millimeter waves, and subatomic beams. They claim that the chances for impacts at vast ranges in 2060 are restricted, akin to the hundreds of kilometers projected for space-based nuclear missile defenses in the 1980s by the Strategic Defense Initiative. The airborne laser shot down guided missiles from the air a decade ago, but its fatal range was reported to be restricted to 135 kilometers, making it ineffective against boost phase missiles. The coil laser utilized in ABL has been widely dismissed as a weapon. However, a 100 kilowatt class fiber or solid state laser capable of destroying objects at a tactically important range of a few kilometers can currently be built. Based on the target's resistance to laser energy, distance from the laser, and how closely the power is concentrated on the target, live fire tests and simulations have shown that a sufficiently strong beam may disable or kill targets in a matter of seconds. They anticipate that development in the civilian industry will aid military aims, particularly in terms of reducing the size, weight, and power of laser equipment, making airborne, space-based, and all-domain operations more practical by 2060. By increasing laser power to a megawatt range, laser battles at tactical range might be reduced to less than a second. According to optimistic projections, the laser power will reach hundreds of megawatts by 2060. Improvements in supporting technology may potentially increase the distance and precision of laser propagation from fast-moving platforms. Even pessimistic projections envisions concentrating megawatts of continuous electricity on targets thanks to adaptive optics that can currently correct for moderate amounts of turbulence. In addition, improved beam stabilization might boost pointing precision by hundreds of nanoradians. Lasers on the battlefield. The Army is deploying a 50-kilowatt laser that will be installed on strikers and deployed in 2022 to protect warfighters against UAVs, rockets, artillery, and mortars. Rather than a 100-kilowatt high-energy laser, the Army is now considering a 250 to 300-kilowatt component for its indirect fire protection capability, which is designed to fight cruise missiles. The HEL IFPC system should be accessible to warfighters by 2024. It's also worth noting that when it comes to unmanned aircraft systems, rockets, artillery, and mortars, the benefit of the laser is that we can have a limitless magazine. If you made it this far and you want to see more, watch FIM-92 Stinger, Missiles Destroying All Fighter Helicopters. So, what are your feelings about this insane laser system? Do you believe laser technologies will be widely used in combat in the future? Please let us know what you think in the comment section below.